Okay, we're back. Last part of 29th. I'm doing one from your worksheet. Section 3.1, number 34. Okay, this is from your worksheet. 12 and 13. It's very similar to one I did before, but it's always good. A prime t or dA dt is equal to 100 e to the 0.1 t. And I want to know t between 0 and 10 hours. What's going to happen, is that 10 hours from now? So I use the integral 0 and 10 integral. Now the integral itself, it's just the exponential chain rule, number 3. To find a equals 100, u equals always the power of the exponent, 0.1 t. F of x, there's nothing there but a 1. So du dx is 0.1. Plug into 3. The chain rule exponential. At, the function, becomes 100 e 0.1 t, 1 over 0.1, 0 and 10. That's going to be 1,000 e to the 0.1 t, 0 and 10. The difference in this one is the other one was negative. So now we have 1,000 e 0.1 times 10 minus 1,000 e to the 0. Okay, so this becomes 1,000, and that's going to be e to the 1. I'm not sure how oh yeah, but times 1,000. Okay, I think I skipped that step now. Oh no, 1,000 e to the 1. Minus 1,000 e to the 0. And what you get here is 2718.3 minus 1,000. E to the 0 is 1. So the final answer, what you get, A after 10 years, whatever A is 1718.3.
That's kind of nice. It's an exponential you can do in your head.
That's what? Right.
If you know what E is.
Yeah, you can actually do that in your head if you know what E was, right?
2.7182, yeah.
Okay. So that's another example. And let's go on and do a third example. Section 13.1. I think I'm going to skip that. It's sort of like this. Okay, and I want to go into present value and future value. Now this is presented in 13.4, but I've given you problems on it in 13.2, so it doesn't make any difference where I present it, because I'm presenting it now in the class. And you will find problems like this on the final. Definitely. So, we're going to talk about present and future value. Remember these, we can talk about annuities, we can talk about anything we want, but we're going to define ourselves to things that are compounded continuously. Obviously, we're talking about continuous functions. We did stuff in the QBUS-110, compounded quarterly, every month. Here it's going to be compounded continuously, and we knew that always had a little exponential involved. So let's look at the formulas. They've developed continuous present value. So if I want to find the present value, PV, we have a formula. This is going to go from 0 to K. Okay. F prime T multiply times E to the minus RT dt. That's our present value formula. This is present value of a stream of income. So present value is the value of a continuous, and PV is going to be T, which is really what you have. I tend to leave out the T. So PV T is the present value of a continuous stream of income over a particular time period. In other words, the income that I'm going to make in 10 years from now, what's it going to be worth today? This is very useful if you're trying to find the selling price today of a property that is going to generate income. I'm going to give you the future value rule. So this is the future value of a stream of income. By the way, these rules are also contained in worksheet 12 and 13. So the future value, FV of t, is the integral from 0 to k. We'll see what k is in a minute. And it's f, I'm sorry, there was something before that, right? I forgot this one has a constant before it. E raised to the rk, 0k, f prime t, e to the minus rt, dt. So notice it's very similar to this, except we have a little appendage out here. And both of these exist notice K is the number of years out that you want to look at your income stream. This says, what is the future value of my investment now? This tells me what's going to be the present value if I take all this and bring it out. What is this worth to me now if I want to sell it? Okay, so we can take a few problems on this. And let's do a present value problem. So we're going to do a problem from the worksheet. It's going to be worksheet problem, worksheet 12 and 13, and it's number 37. And what does it say? It says an oil company wants to sell an oil well. Okay, but it doesn't know how much oil well is going to be worth in the what is the present value of this oil well after 10 years. After 10 years, it's going to be generating a stream of income, but its present value is going to be what it's worth today. So we're going to find the present value. The company is going to use the present value over the next 10 years to determine the selling price. Determine the selling price today. Right. That present value means what is it worth today if I assume this income is going to be generated. So R is your percentage over 100. it says here that the income in this case is going to be, I'm trying to see what it is here. Where are you? I don't have the problem. Let's see if I can do it over here. Where is the interest rate here? Okay. The interest rate R is 10%. So it's 10% over 100. Okay. So R is that, and we're going to use the present value equation that I gave you before. That's the integral 0k f prime t e to the minus rt dt. So now I'm determining present value. So let's see what I get here. So what do I have for f prime tv? Well, I'm given that the flow rate, oil obviously, and I'm given for this problem that the flow rate is something 600. Okay, 600 E. This is a very complex problem.
You have 3 minutes.
E to the minus, oh, here we go. Minus 0.2 t plus 5 times e to the r, which is 0.1 t dt. Now notice that's a minus.
There you
go. Now notice this is going to be df. The integral is the integral of 600 e. Let's put these together. Let's distribute that. Minus 0.2 t minus 1, correct? And this is e to the minus 0.1 t dt. I can add these two exponents, correct, Amundo? This is going to be 0 and 10. 0 and 10. 600 e. What's minus 2t minus 0.1 t minus 0.3 t minus 1 dt. That becomes my integral between 0 and 10. This is chain rule, so let A equal 600.
Exponential rule, right?
Chain exponential rule, number 3. Chain exponential rule. Okay, U is going to be equal to minus 0.3 t minus 1. F of t, not f of x now, is going to be equal to 1. There is no f of t. And du dx equals minus 0.3.
Du dt.
dt, sorry. Here it's based on t. All right, so this is going to be future value, present value at time t. It's going to be equal to that. So let's substitute in the exponential function here. Exponential rule. Substituting in the exponential rule. So we're going to get PVT equals A is 600. Keep the exponent. Minus 0.3 t. F of x is simply 1. Du dx is minus 0.3. And that's taken between 0 and 10. First 10 years. That's what we want. So what is this going to be? This is 600. Okay, so that's going to be minus 600 divided by minus 0.3. Well, that's going to give you a negative 2,000. You're going to get 600 divided by minus 0.3, e to the minus 0.3, 3t, minus 1, 0, and 10. And that's going to be equal to 2,000 minus e to the minus 0.3t minus 1, 0, and 10. All right, well, once you have that, now you have basically, I don't think I got 2,000 there. What is 600 divided by 0.3? Let's see. Yeah, I might be right. It is 2,000.
Yeah, that seems right. Yeah.
It is 2,000. I was right in the first place.
Negative, minus.
And it's a minus. So now I have to do the fundamental theorem of calculus. E to the minus what? 0.3 times 10 minus 1. That's the exponent. Subtract that from what? Minus 2,000 e to the minus 0.30 okay, 0.3 times 0 minus 1, and the whole thing is like that. Okay, minus a minus. All right, let's carry this further.
So we went over a couple minutes ago, but YouTube hasn't been complaining about going over 15 minutes.
Well,
so hopefully we're okay.
Okay, so this is going to be minus 2,000 e to the minus what? What's 0.3 times 10? 3, right?
Sounds right to me.
3 minus 1 is minus 4 plus 2,000 e to the 0 minus 1, so it's minus 1. And I'm not going to bother to bring that out any further. I'm going to give you the answer is 699. But in this case, present value is in dollars by thousands. So it's in thousands of dollars. So the answer here, present value after 10 years, is $699,000. Now, this is what they're going to sell the oil well for. If they're selling the oil well based on the stream of income generated over 10 years, well, what that would be worth today, then that's their selling price, approximately $700,000 for an oil well. Not sure if that's a going price.
I guess it depends on the flow out of the well.
Having never sold oil wells before, I've sold a few oil cans when I was working my way through college, but not any oil wells. How much time do we have?
We're way over. I think we should wrap it up.
Okay. We have now, I'm going to do one problem, future value, problem in distribution of income, average income, and then we actually are finished with the course. And whatever time we have left over, we will review. So I will see you on Friday.